So I wanted to make a video about domain, which is one of the most important parts of a function. So we learned that a function is basically a rule that assigns to each input and output. And so let's take a look. We've got some formulas over here on the left, but let's look at this function, the square root of x. I'll go ahead and pull this back. So if we sort of look at this, we see that if the x value is 4, well, the square root of 4 is 2. And so that's why we plot this point up here at 4 comma 2. And one question we can ask is, what is the domain? And this is maybe something to write down. The domain is just the set of allowable inputs. And so if we look at a graph, we can say, oh, my input can be 1, my input can be 2. It could even be 0, because we've got a point here on the graph. But it doesn't look like my input can be -1. There's no point on the graph here. My input can't be -2. So it looks like our domain is just going to be those numbers greater than or equal to 0. And so maybe if I type this over here, probably not going to like that, but domain is all numbers greater than or equal to 0. Okay. So maybe I'll remove that. So, and that makes sense, right? With a square root, the main rule for domain is that we can't take the square root of a negative number. So let's move on. Let's look at the next one. Well, let's see. So let's take a look at this graph. Let's zoom out a little bit. It's a nice graph. It's called a hyperbola. And if we look at this graph, we see that, well, 10 is an allowable input, so 10 is in the domain. 15 is an allowable input, so it's in the domain. But we look here, there's this sort of weird point here, 5. And if I look and say, well, what happens if I plug in 5? Well, I look and I see there's actually no point on my graph. It's sort of going off to the top of the screen and the bottom of the screen. And so 5 is not in our domain. And if I go and I look at our formula for what we just graphed, our formula that we just graphed, well, I can't plug in x equals 5, right? If I think of this function, maybe I should write it this way, g of x equals, maybe this is f of x equals, if I think of this as g of x equals x over x minus 5, well, I can't plug in 5 because I'll be getting 5 divided by 0. And I can't divide by 0. That's not a defined property. So here the domain will be is all numbers except for 5. Okay. So that's the second one. Let's move on. Let's do the next one. So I'll sort of show you a picture. It looks like a straight line, but we see we've got an open circle here. And in math, when we have an open circle, what that means is that we aren't including that point on the graph. And so again, this means that 1 is not going to be an allowable input because there's no point on the graph above it. And if we want to say, well, what's going on here? Well, if we go back and we look at our formula, let's call this function h of x. Then we see that we can't plug in 1 because we would have a 0 in the denominator. In fact, if we want to check that, if we try h of 1, we see that we get undefined on that line, right? And so here, again, the domain is all numbers except for 1. And the reason for that is because we cannot divide by 0. Okay. So that's going to be for h of x. Okay. So let's just do maybe 2 more. So here's a function. I've defined it in sort of a funky way, sort of a weird way, but let's just look at the graph. For this one, we'll just be looking at the graph because it's not so important how it's defined. And when we look at this graph, we see it's got a lot of different behavior. To the left, it's this kind of curvy parabola. In the middle, it's this wave function. You might think of waves in the ocean or a sound wave. And then over here, it's a straight line. And so again, when we're thinking about what's the domain, it's going to be what are the allowable inputs. So 4 is definitely allowed, 3 looks to be allowed. Any number in this range from 1 to 2 is going to be allowed, but things like 1/2, things like 0.7, things like 0.1, those aren't going to be in the domain, nor are things like 2.5 or 2.2. So just by looking at the graph, again, when we're talking about domain, we're looking for the x values that we can plug in. And so if we were to maybe type this here, let me just do a new line. Domain is, maybe let's write it with interval notation. So we might write something like -infinity to 0. So that's going to include all the numbers to the left of 0. And then we usually write a U for union. Then we're going to include the numbers from 1 to 2. I've used closed brackets here. It's kind of hard to tell in this picture that we're including the endpoints. That's not something to worry about. It'll be clear if you're asked to do that. And then finally, maybe from 3 to infinity. Okay. So if I were to say what the domain for this function would be, it's going to be all of these points to the left, then the numbers between 1 and 2, and then the numbers from 3 to infinity. Okay. And now finally, let's look at this last function here. So suppose we had to check the domain of the square root of x squared minus 1. Now, one thing we could do, and we'll do that in a second, is we could go on Desmos, we could graph this function and see what we get. And, right, well, let's just do that and we'll see what the answer is. So it looks like the allowable inputs are going to be numbers bigger than or equal to 1, and numbers that are less than or equal to minus 1. Okay. So if we look at those, we say, okay, well from that picture, I can get that, but how could I have gotten that without the picture? Well, this is actually something we're going to look at in one of the homework problems. But one thing that you can do is you can think about this. You can say, well, you know, if I've got to have a function, let's call this function, I don't know, p of x, if it's going to be the square root of x squared minus 1, well, what do I need to do? Well, I need to take a number x and I need to square it and subtract 1, and then I need to take the square root of that. And now I'm thinking, when could I run into problems? When could I get something that's not going to be defined? Well, I can always square a number. I can always minus 1. I can always subtract 1. And, well, but I can't always take a square root. I can only take a square root if my number is greater than or equal to 0. So, what if I were to graph this function y equals x squared minus 1? Well, if I do x squared minus 1, if I were to plug in something like 2 and I do x squared minus 1, I'm going to be up here with the number 3. If I do 1 squared minus 1, I'm going to be down here at a y value of 0. If I do 0 squared minus 1, I'm going to get negative 1. And so now if I do that and then I'm going to take the square root, man, what could happen? Well, if I wound up with a negative number, those are going to be these points down here below the x-axis. I'm not going to be able to take that square root. And so if I want to do x squared minus 1, get a positive number or something at least 0, and then take the square root, I better make sure I'm in this part of the graph over here to the right, or this part of the graph over here to the left. And if I put the square root graph up on there, we kind of see this is exactly what's happening, right? We are only able to take the square root when the green graph is positive. So the green graph is negative here in the middle. And that's why we're getting our domain as we saw earlier. So this last example was a lot harder than the other ones. There's a lot of conceptual thinking going on. I would recommend coming back to this example. And like I said, we're going to talk about this on the homework. But the more that you can get yourself thinking about what's the relationship of this parabola with positive, negative, with square root. Those sorts of thinking patterns that you're doing are going to be really valuable in this course. So thank you for watching this video, and I will see you soon. Bye.